All right, folks, welcome to today's webinar. Today, we're going to be talking about manipulating and updating Civil 3D pipe networks outside of Civil 3D. My name is Kyle Groves. I am a senior technical specialist with ATG USA. See my email down there at the bottom. I'll show that up toward the end of the presentation. But that's what we're here for. So thank you so much for all of your time to come in and check this out. A little bit about myself. My name is Kyle Groves. I am an EIT. So with that, I am a senior technical specialist with ATG. I'm out of the St. Paul, Minnesota, geographically, reporting to our broader Twin Cities office. I'm a Civil 3D certified professional. I'm an Autodesk certified instructor, and I do also have that engineer and training certification. My product expertise generally lies in AutoCAD, Civil 3D, storm and sanitary analysis, as well as InfraWorks. So that fits right in quite nicely with what we're going to be here talking about today. So we're going to do a brief overview of Civil 3D pipe networks. We're not going to go through everything about them, but for those that may not be quite as familiar, we'll review why we like them, but also some of the challenges that come along with working with Civil 3D pipe networks. And that's going to transition us into our discussion of the tool Pipe Planner from CTC Software in their CIM Project Suite. Of course, as always, I prefer not to spend too much time inside of PowerPoint. So we're going to go through after that baseline information is put down, get right into the software and start using this for some of our workflows for pipe networks as well as Pipe Planner. So Civil 3D pipe networks, what are they? Why do we like them? Well, they're purpose-built parts. I can come in, I've got this thing called a part catalog, and I can say, look, I need RCP pipes. They might be anywhere from 6 inches all the way up to 60 inches in size and everywhere in between. So they're the closest thing that Civil 3D has to parametric modeling in the way that Revit has for their family object types. And they're really great for our plan production. They're really great for modeling and understanding where these things all are in 3D space. They put themselves into profile view. They automatically scale for our vertical exaggeration. Their labels are very dynamic and they're great, but getting these tools to actually put together a functional design is challenging, to say the least. So our pipe networks are very data rich. We'll see that when we jump into the part properties of those and what label elements we have available. But again, they're really clunky to work with. And the thing that we're lacking is context. So with these parts, with these tools inside Civil 3D, I can see what one individual part is doing, or what all of my pipes are doing, or what all of my structures are doing, but that's not really how we design these networks, these systems. We like to see things in a pipe run. What is happening to these pipes as they go across the structure? So the other thing too is that we've got really awesome labels. I said these are plan production tools and the labels are dynamic. We move the invert up, the label changes automatically. We add a new pipe to the structure and we get that data showing up with that label. However, our reporting information and the tables that we can produce for these, yeah, they exist, but they're really inflexible. And I don't work with many firms who use them as part of their regular deliverable process. Lastly, when we're analyzing these pipe networks, we have to run water through them. We have to run sewage through them. That means we need to be concerned with what our inputs are, how much area is going through these, are the pipes steep enough, right material, all that other stuff. And Civil 3D Autodesk has slowly been introducing new elements to help us out with that. There's been the HydroFlow storm sewers extension and storm and sanitary analysis for some time. Those are free and they come with the software. The Analyze Gravity Networks command was introduced in 2018, and Autodesk has been making slow but steady progress in building that one out. But they're kind of complicated to use. And so a lot of firms like to use their own spreadsheet, typically with a rational method, but they like to use a spreadsheet that says, here's my area, here's my slope, here's the structures that I'm attached to. And that helps them do their sizing and their routing for these pipes. But then they still have to come back in and they have to type in that data by hand. So that's why we're here today. And that's what Pipe Planner is going to do for us. Now, I'm going to just go ahead and turn off my video so that we can stay focused on this for the rest of the session. But with Pipe Planner, what we're doing is we're giving ourselves the ability to modify these pipe network objects outside of Civil 3D. Actually, we can do a good chunk of that inside Civil 3D too, if we're so inclined. But in order to do that, we need to do a couple of things. Number one, we have to lay these out using the pipe network toolset in plan view. So yes, we can change inverts using this tool. We can change the sump depth, but we're having a hard time, or rather we need to have the X and the Y coordinates figured out at least for that. Once we've got those all laid out into plan view, then we can start building our table. We can take that data and work with it directly inside Civil 3D, build some columns, run some formulas, or we can spit this straight out into Excel. Once we're there, we can run our calculations. We can make bulk changes to that. It doesn't just have to be inverts, but once we understand what these changes are supposed to be, our spreadsheet has that information. Now we're able to just suck that data right up into Civil 3D, and that process is going to apply those updates that are different from the spreadsheet versus the model. This is going to allow us to plug in directly to our company H&H spreadsheets. We can add in custom columns inside of the Pipe Planner toolset, or we could simply spit it out as is and then run some cuts and pastes to move things and migrate them into our spreadsheets. Also, I mentioned this before, but this tool allows us to update more than just our inverts for our pipe network objects. This allows us to swap parts. So I can go from a 16-inch to a 24, or an 18-inch to a 24-inch part. I can change the properties of that part. I can create manhole, or I can create reports, all kinds of different things. Pipe depth, creating schedules, do a little bit of quantity takeoff information with my lengths and my numbers. Really, the point with this tool is if you have a part in your drawing and all of the information that the tool can read for the various pieces of data available, that's the table you can build. That's the data that you can play around with and manipulate. So with that, that is it for our PowerPoint. Let's hop right into the software and see this tool in action. So here I am inside Civil 3D. I am in version 22 today. That is going to make a little bit of a difference for this tool, but we'll get to that when we get there. And we're looking at a pretty straightforward roadway project. I've got a 36-inch pipe run coming down. You know what? Actually, I was playing around with this earlier. I need to get a fresh file loaded up. Same stuff. I just want to get back to that baseline condition. Now, these are the same files that you would see should you decide to call up ATG for a demo of this tool set. The beautiful thing about that too, though, is you can download these very own files yourself, and you can follow along with this recording and try out working with some of these different functions that we're going to do. But we've got a high side to the west, we've got a low side to the east. That's how we're draining. We've already got this stuff all put up in pressure network. Profile view. That's not a pressure network at all. And we've got these, simply labeled in plan view. So I'm going to go ahead and start right off the bat. I'm going to go to my CIM Project Suite ribbon inside my software, which is going to happen once I download those tools and get them installed. And I'm going to go check out my pipes panel. Now, hopefully by now you've heard of the fantastic tools for Pipe Designer, our part tagger tool, and our part swapper tool. Pipe Planner is giving us the ability to do a lot of those individual functions and start combining them into one. So with Pipe Planner, we have those two functions. Our first function is that we can build this table up and export that out to Excel. And then we can, of course, take that spreadsheet and pull it back into the software, updating it much in the same way like we would see from our Manager Suite tools for our layers and our description key sets and all that stuff. So I'm going to run my sheet, and it's already got this table put together. So the tool, like many of the other tools in the CTC suites, does remember what we had in here last time, so we can continue to work with it. However, we also have an opportunity to save these out and reload them later on. If we go into the options for our tool, we'll dig into this a little bit later, but we have some file paths that we can deal with for that, as well as some other settings to just kind of help out. But I'm going to go ahead, I'm going to clear all this data out because I want to show you how this tool works before we get too much farther along. So when we open up this tool, we've got an interface that's a little different than anything else we've seen inside the CTC suite so far. On the left side of the dialog box, we have all of our parts available from the drawing. We can look at both our structures and our pipes, just our structures, or just our pipes. Also, we can use parts from multiple different networks. So we've got, I'm only going to be working primarily with the storm, but if I come in here and add in my sanitary, I'll see that those different naming formats show up. If I remove the sanitary from my list, they'll go away, and I'm just stuck with P1 through 20. I can, like I said, just work with my structures, or I can deal with everything. When we take this data and we play around with our little add or removal arrows, we're gonna be adding columns. Sorry, we're gonna be adding rows to our spreadsheets. On the right side, we have all of the various pieces of data that are available to us. So data that is in white is editable data. Data that is in gray is dependent data, and we're not allowed to directly modify that. When we add this stuff to our table, that's going to give us our columns, and then everything's going to show up in the middle where we can start manipulating and playing around with that. So I'm going to go ahead and I'm going to start off by not adding everything. I want to choose a specific pipe run. As I brought that up earlier, I think it's important to come back to that. When we're choosing our parts to add to this table, we do have a nice green pick cube for that. Now, we can just start running around and doing stuff, but as I like to encourage my students to do, go check your sub commands from your command line, and we'll see that we have a pipe run option. Now I'm going to work myself from high to low. So I'll go to the west side. I will go to my eastern terminus, where I can also see that I have that upsized to a 48-inch RCP, and everything in the middle was grabbed. Now that I press enter, I'm going to start seeing this stuff populate a little bit. Now, this ID handle, we'll get to that in a minute, but I don't have the actual name or the description of my parts listed out in this table yet. So I'm going to go to my structure tab. Actually, sorry, I'll stick with the all. And then I'm simply going to come over to this properties. I'll find my general name. I can control and shift select to multi-select various pieces. So I got my name and my description. I'm going to add those over, and now we can see that our columns are starting to get built out. From here, I'm going to go into my structure table and do some more specific information. We'll see that we have lots of different categories of data. So this is the type of stuff that we would expect to see the headers inside of our part properties dialog boxes. But I've got lots and lots of different info in here. So for my structures, I care about my rim elevation. I'm also going to try and go find my sump elevation. Note, there's one quirk with this tool / the Civil 3D Pipe Network toolset in general. We don't actually get to refer to the bottom of our structures as the invert. It's treated as the sump. So even if you're not using an actual design sump value, you just want that invert to be right next to the lowest pipe. Civil 3D is treating that value as the sump, not as the invert. So structures, description, rim, sump. Let's see, what else might I want right now? Height's usually a useful parameter. I don't need any of that other stuff. We'll get to catchments later. And I'll, yeah, that looks good for my pipes. Let's go, sorry, for my structures. Let's go look at our pipes now. So because I chose that run and I only had my trunk line stuff in there, I'm seeing that all of those laterals at different numbers, they're still off on the left. So these are not going to be added to my table. I could add them over, or I could remove them. Just have to use these little arrow buttons off to the side. For my pipes, the properties that I'm going to be interested in now, let's see, let's grab our start and end inverts. Let's grab our minimum cover. Let's grab 2D length center to center, and see if I can get my structure. I know it's in here, I just have to find it, but what structures I'm connected to. Start and end structure. So I'm building this table out. All I have to do is decide which parts I'm interested in and what data that I'm interested in. Once I'm ready to bring this out into Excel, I'm going to go ahead and come down here to the bottom left part of my screen, or really kind of think of this like the bottom ribbon. So our first question is, where are we going to move this file to? Well, this one gets a little interesting. So the tool won't actually write the file for you. You do need to create yourself an empty shell of a file. I'm going to call this one test because I do want to come back to that if I need to. So you got to actually create an empty shell of a file first. Or if you had your company's spreadsheet, maybe you'd copy that into your project location. So first thing I'm going to do is I'm going to create the file, then I'm going to select the file, and choosing that open button is going to run that out. Next up, I'm wondering, am I going to be writing to a new sheet or to an existing sheet? And when we're saying sheet here, we mean those little tabs inside of Excel, just like we have layouts inside of Civil 3D. So I'll write to an existing sheet. I can choose which one of those. Again, if I had multiple, that's where I get to choose from. And I can even choose my starting cell. So we could type that in, or we get a preview of what this spreadsheet's going to look like, and I can go actually pick what that top left corner is going to be. Do I want to include my headers? Yes or no? Maybe I want to put my structures, my pipes on different tabs or different sheets. That's all an option. From here, I like this, and I'm going to simply say export, and it's going to prompt that to load up, and it will auto open the file for me that came up on a different screen. So here I am right inside Microsoft Excel. So a lot of times people will like to kind of preserve this data and they can start making a copy of it and manipulate that. I'm just going to work right within here. So we've got a couple of different things that we can do. In this table, it's telling me what is directly editable, what is not editable. Excel, however, is not giving me quite that same information. So I do need to use some judgment to make sure that I am not trying to overwrite data that is being controlled elsewhere. So what I can do is I can change the name of my structures. I can change my description, and I can also, of course, come in and modify things like my inverts. So let's see. Does anybody here know a contractor who can build a pipe invert to 0.27? I know I sure don't. So we can start doing anything else that we like in Excel here. So maybe I want to use the round function to get these all stated out within a tenth. So I can say equals round. My number is going to be right there, and the digits are 2. Actually, it's been a minute since I've used the round function. So let's play around with that. There we go. So by using 1 digit, it's giving me that now. It's rounding it up to 0.2. If I grab that, cool, copy this, put it on my clipboard, paste the value. Same thing, grab that over there, bring this down here, copy again, paste value. So I can use this to very quickly go through and do a lot of different edit operations inside. I can change my inverts. I can start changing my sump elevation. If I go back to Civil 3D and I take a look at my profile view, it looks like my minimum or my low point is around 773-ish. And, hey, maybe I want to just use the equals minimum function that I can come through and figure out what the bottom number of that range is, 773. So this would be a really weird thing to do, but I'll do it anyway. I'm just going to say, hey, look, all of my sumps are going to be at the exact same elevation. Or all of my inverts are going to be at the exact same elevation. So what I'm going to do now is I'm going to save this spreadsheet as it is. I'll come back into Civil 3D, and we'll take a look at what this would be doing when we're trying to import this data. I'll go through a couple different iterations of this. So this isn't the only thing we're going to do, but I'll go grab my new sheet saved a minute ago. I'll open that sheet, and I will choose which tab from within there that I'm trying to load. So I've got that first one, and now this is great because the tool is telling me, hey, if I don't have something that's already existing inside my drawing, it's going to be red. I'm not even going to deal with that. Actually, I'll come in here and let's add one of those. 1, 2, 3, 4, 5, 800, 5, 180, S11, S10. And P52, 48-inch RCP. If I save this sheet, I can just go back in, I can refresh it. If I scroll down to the bottom, it's going to say, hey, man, we don't have a P52. You're not going to be able to build that. We need XY data. We need a lot of other info. So I'll come back into my spreadsheet, wipe that out, save it again, refresh the sheet, and it's going to tell me what all those new values are going to be. So that's how easy it is to use the tool. Next up, let's try a couple of different things with this spreadsheet. So I'm gonna go back into the tool. I'm gonna re-export that. We'll save over those changes that I did earlier. No, it's not gonna save it over because it's open. Windows we still don't get to break the Windows rules, even though we get to break AutoCAD's rules. So what else can we do in here? Let's try some updates. Well, typically, A lot of things in Civil 3D function on a basis of a name. So if I have a block and I change it in one drawing, but it already exists, and I bring it back into the new drawing, it's going to use that existing definition. So we have this ID column set up here so that this is the name that's always going to be the same. And now I can do stuff like change that name. So I don't want this stuff to read out P8. I want to change this. So I'll do a little bit of find and replace. I'll take everything that currently says P and we'll call that pipe dash. I'll say replace all, and that works. I can also come in here too, and I can do other things. So like I said, if you have your existing, maybe it's rational method, maybe it's some other type of spreadsheet to go and recalc your inverts, recalc your slopes and your sizes and the rest of that stuff, this tool will help recognize that too. So in my description field, that's a common place that people use to track this data and to use labels and things like that. So if I go check my part list for this particular drawing, let's look at my storm sewer, and I will see that for my concrete pipe, I have all of these various RCP sizes. So as long as my spreadsheet has a description value that matches one of the other descriptions inside my part list, we're going to see a change in those sizes. So I'm going to take all of this and convert my 36 to a 42 to upsize that trunk line stuff. And then I will take this 48-inch one, and I'm going to give this a known bad value. So like 27 inches is a reasonably uncommon value that I would expect, at least up here where I'm at in Minnesota. So what we're expecting to see here when we re-import this data is we're going to see the names of these pipes change, and we're going to see most of those pipe sizes change, but keep an eye out for this pipe number 8, the one that was a 48-inch RCP. I'm save my spreadsheet. We'll come back in. We'll run our import. Choose that same file. Grab that sheet. And now we've got our pipe names and those pipe descriptions set. So I'm gonna run that import command. We'll see this stuff, update the drawing. We get the little warning. And if I go check my, well, I can just look right over here. So 42 inches, that was in the part list, that happened. However, this is a lot bigger than 27 inches. If I go into the pipe properties for this particular pipe, it is going to tell me that it is in fact still the 48-inch concrete pipe. However, it's got the new description. So just keep that in mind. If you're trying to use this tool to replace some of those functions of the part swapper tool, it's our free tool for pipes in the project suite that you're already using, then just note that it's the description that Pipe Planner is using to keep track of all of that. So that was a couple of things we can do. Let's try some other stuff. Now, Pipe Planner does allow us to build these sheets. We can do it right here inside the drawing. We actually don't have to export out in order to go through and make some of those other changes. You remove those columns. Let's do some stuff with some structures. I'm gonna remove all of my parts from my whole table. I'll just go to all. I'll click on the big chevron over there. I'm just going to add every single structure that I have over to my drawing. Now it's going to sort those by name. That's great. I've still got all this other data. Maybe I want to bring in my frame, grate, and cover. I can bring those in. That's stuff that part tagger might be responsible for working on anyway. So my frame, I can call that a frame. My grate, yeah, these are not necessarily values that I would expect to use all the time, but I can copy them and I can just drag over my cells and I can paste those in. It's going to recognize the columns, it's going to recognize the cells, the rest of that stuff. Maybe I want to recalculate my rim to sump height manually. I don't like all of these 4 decimal places. What I can do is I can insert columns, maybe left, maybe right, and I can just go ahead and remove that other rim sump to height column. And now if I want to take my rim, I just type in an equal sign. This is exactly like working in Microsoft Excel. So I'm going to take that, I'm going to do my minus sign, I'm going to run my left arrow key to get back over to E3, and it's going to report that back out to me. So that's my rim to sump height. Oh, I missed my first one, and I'm able to calculate that. So I can do this all right inside the tool. I don't have to go out to Microsoft Excel. I can write all of this up just this way. I'm going to rename that header though. We'll call that struct height. And there we go. So what else? We can also do those renaming or those part swaps in here. So I want to call this MH number 1 dash 1, call this MH dash 2. And now since these values, oh, those were catch basins, not this one, S2. So these manholes, if I change that to MH dash 3, MH dash 4, I can actually just select these first two. And now this drag drop in the bottom right, this is going to be applying the actual formula. So I'll go down to structure number 11, which is my manhole, and it's going to count those up for me for all the rest of these catch basins. CB-1, CB-2, CB-12, CB-13. Sure, whatever, equals sign. That's cool. Doesn't matter. At this point, since I'm not exporting, I actually just want to hit the apply button and or OK. Same rules as those apply. So if I hit OK, it will do the changes and it will kick me out of the tool. If I zoom in over here into my drawing, I'll see that I've got my MH5 showing up for that. My prospector is going to show me for my structures. Oh, I think the equal sign was throwing in, we can't use that syntax as part of our names. Catch basins 1 and 2 made their changes. Manholes, all the manholes kept theirs, but that equal sign did not work so great for the rest of those catch basins. So that's the type of stuff that we can do. And with these reports that we're building out, we can build these for whatever data we want. One thing I will mention is with our ability to save these tables out and load these tables out, I'm going to load up that very first table that I had. In my options for this particular tool, I've got where I'm looking for all of those different things. So this is a place that I can point to on my company standards with all the rest of my profile information on my plotters and my templates and that stuff. Or I can put these specifically into my project that I'm working on right now and collect all that data together. So with that, I'm simply going to load up that very first table that I had. And I wanted to mention that I'm in version 22 for a very specific reason. And that is in version 22, Autodesk opened up the API. That's, I forget what the actual acronym stands for, but if you can write code, you can talk to anything that's exposed in the API. It's a little window into the software for different things that you can manipulate or read or do math on. In version 22, Autodesk opened up our Civil 3D catchment objects to that API. So we can read that now as part of our structure data, as long as we have a Civil 3D catchment mapped to that structure. So this is how we're getting the power to create those tables that we can then spit out and work with our hydrology stuff. Because we've got those catchment areas, we can even do our runoff coefficients. Now we can really start playing around with how much water is this structure going to take, how much is going to get passed on to that pipe downstream of it. Are these pipes big enough, steep enough, etc. So you'll find that in here. I'm not going to go through all of these different pieces of data. Just suffice it to say that if we can find it in the API, then you can read it here in this list. And if it's in this list, you can add it to your stuff. So all these different categories worth of data. A couple of UI improvements to be made here. Like if I do change or move some data around, like those all get flown back open. So love to see a collapse all or an open all and to get some of that behavior read in. But the great thing about CTC, they're super responsive to their users. If you do have a wish list or something else like that, all of the tools have a very similar top ribbon. So if I click on that support button, it is going to take me to a web page where I'm going to start filling this out, and I'm going to make a wish list item for support. Now, if you're in USA, the United States, that's coming through to us, Team ATG. We'll evaluate this, and then we'll send that on to CTC properly. If you're internationally, Canada, that'd be SolidCAD. I believe they just picked up an Australian reseller too. But these tools are supported. They are developed by users. They're developed for users, and they care a lot about the feedback. A lot of the functions inside this tool were built by that feedback. from CTC, we had it that some firms were like, okay, yeah, cool, but I don't want to lay this out in 2D. I just want, like, I have a super cool magic button spreadsheet. It does everything for my pipe network, as long as I have the XY coordinates. So that's now in here. If your magic sheet does all the magical things, then this sheet can talk to it. There was also a couple of our tools that were made in collaboration with other client firms. Point file converter is one that was proposed and jointly developed by a client. Data Wizard is another one. I'm seeing some individuals from that firm today on the webcast. Sheet generator, again. So if you have ideas for these tools, let CTC know, and you can do that right here through the support button inside the tool. What else do we have going on in here? If you click on your about, that will take you so you can check your version and check that against the latest. And these videos tabs are super cool because this is going to take you directly to CTC's YouTube page, where every video related to a specific tool has already been compiled into its own playlist. I really, even though you're here watching me at ATG give this presentation today, I love watching CTC's webinars when I'm trying to learn a new tool, or I recommend this very much for for that foundational learning. The ATG webinars are typically a little bit more focused toward, hey, here's an existing workflow, let's make it better with the CTC stuff. So little detour there into some of the rest of that. I do have one more thing that I want to show you that is a bit unique. We've talked about adding columns. We can reorganize them, insert fresh columns to recalculate or to calculate fresh values and such. But if we take our pipes, and I'm just going to go ahead and remove a couple of these pieces. You know what I'm just going to do? I want my remove. I'll back on. I don't really care about my inverts. I just want my lengths. And I want to know how deep certain pipes I have, or like how much length is a certain depth beneath the ground. Well, if I go check my data on the far right over here, I've got this new category called calculated fields. These are custom formulas that CTC has already put together for us. They've got a few more in the hopper. Definitely let them know if you want some other ones. But this pipe depth at interval is a really interesting one. So as soon as I add this to my table, it's going to start breaking out some values. Well, let's go check our options. And this is going to give us more information for what exactly is going on here. So the bottom series of data and information is for this pipe depth calc. So do we care about going from the top surface just to the top of the pipe, or the actual top of the pipe? Do we want to go to the crown, to the invert, or the actual bottom of that pipe? This is going to help us do our trenching quantity takeoff analysis. And with this range, you know, right now 2 is kind of tight. I'll change that to 5 instead. And then the sample interval, well, I don't know what that means. What does it mean? If I hover over this little question mark, it's going to pull up that help for me. So length of depth interval is how often parallel to the pipe, basically my station along my pipe run, how often am I sampling for that? So if I do this at every 5 feet, it's going to give me a pretty solid indication of how much of this pipe is happening. Now, I was just in conversation with CTC earlier today about this calculation. So fundamentally, what we're doing is we're looking at the minimum depth across the whole range, and that's where our start value is. So the shallowest pipe is around 4 feet long, and then my range is going forward by that increment of 5. So if I go back into my options, and I change this increment to 10, we're going from 4 to 14 feet, and actually that's all the pipes that we have. However, if I go and I do this with a 2-foot increment, I'm still starting at that 4, but I'm breaking this out 4 to 6, 6 to 8. Apparently I don't have anything from 8 to 10, and so on and so forth. So do with this data what you will, kick it out into Excel, run all the formatting that you want to run, and use this tool to help yourself build those manhole schedules, build those compound pipe and structure tables. As long as you have pipe parts and structure parts to read from and all of this data to deal with, you can build whatever table that you want to build. Now, to kind of go back and review, I did miss this at the front. Why do we need this tool specifically? Why do we need these other tools in the CIM Project Suite? Well, working with our pipe networks natively is pretty tough once you get them laid out in plan view. Yeah, you can get them projected into profile view, but oftentimes you'll see something kind of like what happens in this file. You've got pipes that are upside down. You've got a low point where you don't want a low point. You've got weird zigzag, zag, and sawtooth patterns, bad drops, weird matches, and all of that stuff. So improving how these are getting laid down is a big concern. Yeah, we can come into our profile view and we can do some graphical edits and we can like snap stuff on top of each other, but that's really hard to get your 0.1 foot drop, particularly when we're dealing with vertical exaggeration in the profile view. So that kind of sucks. Let's see, if I go into my pipe editor and I edit my pipe networks, I can go check out my panorama and see what this information has. And my pipes give me a ton of information. I have 3 monitors right now. I'm just going to try and make this as wide as it needs to be until that scroll bar goes away. And this is just over 2 monitors, just about 2 monitors worth of data. If I take every property that Civil 3D wants to get me, this is largely just not usable. I don't need all that data. And I'm only being presented the context of just my pipes or just my structures. I can't do that pipe run format. Now, there is this new tool, newish tool for AEC collection subscribers. This goes all the way back into version 2020 of Civil 3D. It's called Project Explore. This is the biggest improvement in working with pipe networks. It does many things other than pipe networks, but working with pipe networks, it does a pretty good job of giving us that context. So we've got everything in Project Explorer. We've got this context on the top for the visual. We've got some medium level like parent object, the parent network up here, and then down in the bottom third is the most detailed information. All this purple stuff, like the pipe tools, I can come in and I can rename this description right here. I can rename the part. I can start playing around with some elevations and dealing with all of that. But again, don't really have that context that we're looking for. Though we do have this option to do a pipe run edit. We're doing this in pretty big bulk though. Like we can say go down from here, or we can say go up from here. We can put the same slope on every part, or we can pick the start point or pick the end point, but it's still just not quite giving us that flexibility. Like what happens if this part is a low point? Well, we got to go shallow into it, and then we got to go steep out or something else. Or maybe, hey, you know what, this is actually going to be a low point, and we got to go down into it. So if I've got that whole pipe run, I can't apply a uniform slope and get the values that I'm looking for. That's where this tool comes into play. We've got another tool. Maybe you don't want to leave Civil 3D. Maybe you don't want to do that import-export stuff. Then I would direct you toward Pipe Designer. This is a tool that does still stick with that pipe run concept. I can pick this from plan view or in profile view. And as soon as I do, it's going to give me this spreadsheet where I'm laid out structures on the left, pipes on the right. And as I work my way down the list, my pipe number 1 is connected to manhole 3 on one side, and it's connected to manhole 4 on the other side. So now I can come in here and I can say, hey, set me some minimum cover, or I can go edit slopes. Great. Interpolate between the very first structure and the very last structure. Give me a constant slope. And I can't resize pipes in here, but I can have it interpolate that and I can have it force it. We were very close to a 0.6% for, but now I am. I can play around with what's my drop. I can be dealing with my elevation. So I can go with an invert or with a sump value based off of my structured data. This is not the purpose of this webinar to go through here, but I did just want to point out, hey, we don't always have to leave Civil 3D if we don't want to. So with that, folks, that takes me through how to use today's pipe planner, one of the newest tools in the CIM Project Suite. While it does have some more improvements that can be made, I'm pretty happy with it overall. So let's pop back into PowerPoint and close this out. So what did we learn today? Well, first, we learned that pipe networks have always been a great modeling and plan production tool, but they do leave a lot to be desired for our design workflows and for our report creation. Pipe Planner from CTC Software now brings the power of spreadsheets into your hydraulic design. So we can always create data from any combination of available properties for the report that we always wanted. We can put pipes and structures together. We can split them out. We can create custom formula columns in Civil 3D or Excel. If you've got a formula that you want to use, maybe you want the count function, maybe you want, I don't know, I was using the round function to kind of clean up my inverts and stuff. That's what we can do. And lastly, we can work directly with the calculation spreadsheets already in use at our firms. So folks, I want to say a big thank you for your time. I really appreciate you coming in to hang out with me today. Again, my name is Kyle Groves. You can see my email down at the bottom of the screen. Don't forget to follow us on social media. We're on LinkedIn, we're on YouTube. But at this point, I'd like to stick around for questions and help answer those for anybody that might have them. For the Q&A, do feel free to type into the Q&A, the question and answer panel. It's a little bit cleaner than dealing with the standard chat. All right, not seeing any questions come in yet, though I will, again, stick around for another minute or two, should anybody have them. While we're waiting for that, if for those questions to come in, I will go ahead and just show you, if you're interested, where you can go and find these tools. So the CTC tools that I was showing off today, these are add-on tools. They're third-party, they're a paid addition to using out-of-the-box Civil 3D. But you're going to go to ctcsoftware.com. You're going to go to their products page for the CIM Project Suite, where you can come in to get your download. You can, like I said before, you can work with these files that I was doing today, and you can tell your friends. All of the tools have a little paragraph, a couple of bullet points, and like a 1 to 5 minute video that shows how to do the core functionality of the tool. So with that, did get a question coming in here. Recommendations for existing versus proposed. Should we do it in 2 networks? Should we do it all in 1? How does that affect our analysis, our styles, our labels, etc.? You can do either, really. As far as the analysis is concerned, we do want to keep our existing conditions separate from our proposed conditions. Now, there's going to be times where our proposed, we're not going to disturb every square inch of the site, and maybe we had some off-site run on happening anyway. So we're going to need to collect that stuff. I would actually refer you back, Joel. One of my coworkers, Brian Tanner, did a webinar a couple of weeks ago. I'll go to our YouTube page now, so youtube.com. You can find us up at ATG USA. There we are. And you're going to be looking at the Civil 3D playlist. And this is mostly in chronological order. The bottom is the most recent. May need to refresh itself, but you are looking for the Civil 3D for Stormwater Design webinar. Also, I've got a white paper on this topic, how to set up your Civil 3D model for good hydraulic design. But really, if you are planning on kicking this out to any other software dynamically, you need to have one network connected for each unique outfall point in your model. So if you've got a high line running right through your site that you have to maintain, and you got to drain one set of stuff to the north and one set of stuff to the south, you're going to need 2 pipe networks. Whether they're both proposed, whether one's existing and one's proposed, not so much of the differentiator, but like going to storm and sanitary analysis, those have to be separate networks. You can style things uniquely within the same pipe network. So if I go to my part list in this drawing, pipe network, part lists, stormwater, edit. So I go to my part list, I can actually assign a unique style to each individual part. So when I'm putting this together, I've got my part family. I can add an individual size, and once I have this all in here, yeah, I can start to switch these out. So maybe I don't do RCP for proposed. That's only ever going to be existing stuff. So I can, or it's only ever going to be small existing stuff. So I can call my 15 and my 12 existing. It's in the part description. I can also style these uniquely. Let me just Move this out of the way. So I don't have like an existing or proposed in here, but I do have storm versus sanitary. So I can call these two, my 15 and my 12, something different for the single line sanitary. So your part list is very flexible for handling just that question: what's existing, what's proposed, what do I want to deal with? Styles, your style is probably, normally I like using layer 0 for a lot of stuff. Unless you want to do something kind of goofy, you're going to be using hard-coded layers for your pipe and pressure network objects. So you're going to need that layer for your proposed sanitary anyway versus your existing sanitary. So all that stuff's going to want to be put together like that. Labels too might be beneficial to have an existing style versus a proposed style. The only reason you need different sanitary versus storm if you're trying to do different data for it, or if you wanted the different layer control. It's a bit broad of a question, though, Joel, if you want to, go ahead and reach out to me via email, and I can see if we can get on another call, talk a little bit more about your questions for your template. There might be some good things that we can kind of talk about, just not really beneficial for this specific format. Hopefully I was able to answer some of your questions. All right, anything else coming through? All right, well, with that, folks, I do want to go ahead and say thank you one last time for making today's webinar. My name is Kyle Groves. It has been a pleasure. Have a great rest of your day. Have a happy, safe holiday weekend. Thanks, folks.